Good morning, students. Today we are going to start 11th unit of our crash course, which is magnetic effect of current. In this chapter, we have to take care of directions also. Means you should be careful about not only magnitude, direction of magnetic field. They are giving same options. Magnitude is same, but directions are different. So, very carefully we have to study this unit. So, first I am giving you revision of this unit, then we will start our 45 problems assignment. Firstly, this effect was discovered by Biot-Savart. Biot-Savart law. What is Biot-Savart law? Ki if you have a current carrying element, suppose it is a current carrying element of length dl. He observed that from this element at distance r at an angle theta, magnetic field depends upon these factors. Magnetic field was directly proportional to current. Magnetic field was directly proportional to this length. Magnetic field was directly proportional to sine of this angle. Means if theta is 90, it was maximum, because sine theta is maximum at theta is equals to 90 degree, and it depends on distance of the point from the wire. Combining these all and removing the sign of proportionality, we got dB is equals to I dl sin theta divided by r square, and proportionality constant was mu naught upon 4 pi. Mu naught is known as permeability of free space. And its value is 4 pi into 10 to the power minus 7. Means the proportionality constant is 10 to the power minus 7. This law was very useful. We discussed about the direction. You can use your right hand. Suppose this is a current carrying conductor. You want to check magnetic field at this point. Put your thumb of right hand in the direction of current, finger pointing towards the point where you want to calculate the direction of magnetic field. The line coming out from your palm will represent the direction of magnetic field. And around the conductor, if you want to calculate direction of magnetic field, right hand rule is applicable there also. Put your thumb in the direction of current, curl your fingers, it will give you direction of magnetic lines of force. Curl of fingers will give you direction of magnetic field. It means, suppose it is a conductor. Current is in this direction. If we keep our thumb in the direction of this, thumb of right hand, curl of finger will give you the direction of this. Means you will get magnetic lines of force in this direction, means anti-clockwise. Getting my point? This is the picture. Curl your fingers in the direction of, put your right hand thumb in the direction of current. Curl your fingers, it will give you the direction of magnetic lines. And if your conductor is circular, suppose it is a conductor, I current is flowing in this direction. What we have to do? This is a circular conductor. Curl your fingers in the direction of current. Thumb will give you, for right hand, thumb will give you the direction of magnetic field. It means in this case, magnetic field will be in upward direction. So, using your right hand rule, you can find direction in each case. If point is away from your conductor, if you want to calculate magnetic field surrounding your conductor, you can calculate. So, it was Biot-Savart law. What you did in your 12th class, you calculate for some geometrical figures magnetic field. If we have a conductor of finite length, you want to calculate magnetic field at this point. If conductor is of finite length, it means you are able to see both the ends. It means these angles are known for you, this angle and this angle. Suppose one angle is alpha and another one is beta, and this distance is d, means distance of point from conductor is d or r, whatever you say you can take. You will get magnetic field at this point mu naught upon 4 pi I upon d into sin alpha plus sin beta. They can give you numerical based on this. They can ask directly formula. Now, 3 cases will arise. If your conductor is of infinite length, you can imagine if I am increasing the end point towards infinity, alpha will increase. If this end is moving towards infinity, beta will increase. So, what should be the limiting value of alpha and beta? If this straight conductor is of infinite length, this magnetic field will become sin alpha and beta will become 90 degree, alpha will be 90 degree and beta will be 90 degree. So you will get magnetic field mu naught upon 4 pi I by d. Sin 90 is 1, so 1 plus 1. Means you can get result mu naught upon 4 pi 2I upon d. You can cancel with 4 with 2, but better to remember in this way because mu naught upon 4 pi have a fixed value 10 to the power minus 7. It will save your time in calculation in exam. If conductor is of infinite length, if conductor is of infinite length, conductor is of infinite length and you are means that point where you want magnetic field and point is near one end, means one point is visible to you, means it is of infinite length and point is this. So what will happen if this point is moving towards this perpendicular line? What you are observing, beta will start decreasing. So beta will become 0. Alpha is 90 degree, that point is not visible, but you are near the lower end. So in this case, beta will become 0. So what should be the answer now? Now magnetic field should be sin 0 is 0, 1 is 1. So you will get mu naught upon 2 4 pi. I upon d. So remember all the cases. We have to use this type of cases in our calculation and in numericals. Next, after Biot-Savart law and its application in infinite length conductor, we calculated the magnetic field. Means you calculated the magnetic field for circular coil, taking small element and using the concept of summation. We calculated magnetic field at 2 points, at the center of ring and at axis. What were the formula? At center of ring, or you can say circular coil, whatever you give name. It was mu naught Ni divided by 2R, or you can use capital N because small n we will use for some another physical quantity, mu naught Ni. R is the radius of this circular coil. R is radius and N, R is radius and N number of turns. Next, if we want to calculate magnetic field at a point on the axis, suppose at this point, and this point is at x distance, then magnetic field will be, it is magnetic field mu naught Ni r square divided by 2 r square plus x square raised to the power 3 by 2. It is on axis. So, very important formula it is. You will definitely get either numerical or direct formula. From this formula, you can get this. How to learn? It is difficult for you to learn this formula, but if you can learn this, you can compare. Is it wrong or right? See, if I am putting x0, I am taking radius r, so I will put r square, small r. See, if we put x0, r square raised to the power 3 by 2, 2 will cancel with 2, you will get r cube, 2r will cancel out and you will get 1r in denominator. So, same formula it is. So, if you can learn this, with the help of this, you can calculate magnetic field at center also. Next geometrical figure was solenoid. What is a solenoid? If you can put a wire tightly in helix shape, it is known as solenoid. Means we are taking one non-conducting surface and winding a wire on this, so you will get this. It is solenoid. If number of turns, it is solenoid. If number of turns per unit length in our syllabus, we have only two cases. If number of turns per unit length is small n, then magnetic field at axis of infinite length solenoid it is infinite length solenoid. B is equals to mu naught Ni, mu naught Ni, and magnetic field near one end. For this means one end is visible, same like that, it will become like conductor half of this. Actually concept was that only. If you will go for finite length, you will get alpha and beta. By putting their value, it will become half. So remember these two formulas and keep in mind that only for infinite length of solenoid. one point is on the axis and second case is point is near to one end. So we have to calculate only for these. Now I will tell you which type of questions they can ask you in your exam.